Okay, quadratic inequalities. Our objective for this lesson is to be able to graph quadratic inequalities in two variables and be able to solve quadratic inequalities in one variable. Okay, so first of all, on the last section we kind of did some review on solving linear inequalities in two variables. For example, if I had y is greater than x plus 2. Okay, what makes it linear is that all of my degrees, all of my exponents on everything is 1. And it's in two variables because it has both an x and a y. Okay, and again, our process was to then graph the line. Remember, we graphed the line y equals x plus 2. We checked a point to see if it works, and then we shaded. Okay, we're going to be doing that exact same process today, okay, except instead of graphing a line, we're going to be graphing a parabola because we're going to do quadratic inequalities in two variables where, again, I still have two variables. Let's say y is equal to x squared plus x plus 1. Okay, to where we now have a quadratic because the exponent on my x is a 2 now. So this is going to graph a parabola. And then instead of deciding whether we shade above or below the line, we're going to decide, do I shade inside the parabola or outside the parabola? But the steps are really the same. We still have 3 steps to solve an inequality in two variables. Our first step is to graph that boundary line. In this case, it's going to be a boundary parabola. Again, we use a dashed line for less than or greater than, and then we use a solid line for less than or equal to or greater than or equal to. Okay, again, we still test a point and then we shade. It's really that same process, except for we have to graph a parabola first. So my first step is to graph this parabola. Y equals, instead of y is less than, y is equal to negative x squared minus 2x minus 1. Okay, so we can graph that by hand. First, find our vertex. I'm going to use negative b over 2a to find the vertex of this guy. So negative b, that would be negative, negative 2, so positive 2, over 2 times my a. My a is negative 1. So my vertex is 2 over negative 2, which is negative 1. And then I'm going to put a negative 1 into that function. I'm going to expedite the process. So I want the negative of negative 1 squared minus 2 times negative 1 minus 1, and we get 0. So my vertex is at negative 1, 0. So let's go ahead, let's graph this. Ruler. So I need to graph the point negative 1, 0. Okay, negative 1, 0 right here. Okay, and let's get a couple other points on either side to see what this guy is going to look like. So let's do x and y. So I'm just going to go ahead and plug in a few other points. So I don't plug in a 0. So when I plug in a 0, negative 0 squared minus 2 times 0 minus 1, it's negative 1. So you have the point 0, negative 1. So then it's going to go like that. Let's put a 1 in just to see. So negative, see 1 squared minus 2 times 1 minus 1, negative 4, negative 1, negative 1. Okay, so we have a general idea on what this parabola is going to look like. It's going to be a parabola opening down like this. Ooh, that's not very good. There we go. Okay, so graph the boundary line. Use a dash line for strictly less than or equal to. Well, this is strictly less than, so I need a dash. So I'm going to come in and I'm going to erase pieces of it. Okay, so good eraser is kind of nice to have. Okay. Go erase parts of it. Okay, so there we graphed our boundary line. Okay, and then test a point. So let's go ahead and let's test a point. Before I test a point, I'm going to double check and make sure my graph looks right. So I'm going to graph it in my y equals, just double check. Negative x squared minus 2x minus 1 graph. Yeah, that looks about right. We match. Trace, we have the point 0, negative 1, negative 1, 0. Yeah, we look good. Okay, so just double check. So now we want to test a point. Pick a point somewhere, either inside or outside. I'm going to pick a point over here. Let's say 2, 3. So I'm going to pick the point 2, 3. That's on the outside of my parabola. So now I'm going to check to see, does the point 2, 3 work in this? If x is 2 and y is 3. So let's check it. If y is 3, we'd have 3 less than negative 2 squared minus 2 times 2 minus 1. So is 3 less than, this would be 2 squared is 4, so negative 4 minus 4 minus 1 is 3 less than negative 4 minus 4, negative 8, negative 9. Is 3 less than negative 9? No, it is not. So I know this point up here doesn't work, which tells me all the points inside of the parabola must work. Okay. And again, you can always double check it. Pick a point inside your parabola, like 1, let's see, oh here, 0, negative 4. Negative 1, 2, 3, 4. 0, negative 4. And let's check that point when x is 0, negative 4. So when x is 0 and y is negative 4, so we have negative 4 less than negative 0 squared minus 2 times 0 minus 1. Negative 4 is less than 0, 0 minus 1. Negative 4, yes, it works there. So it works for, so basically what this is telling me is that any of the points inside of this parabola, okay, inside of this parabola, make this statement true. So any of those points inside of there will make that statement true. Alrighty. Okay, so if you turn the page here, we have example 2, an application type process. This is the very first problem we're going to start with in class. Okay, I'm doing an application type process. So we'll discuss that. Oh, sorry. Sorry. Okay, so let's go ahead and, so that's solving a quadratic inequality in 2 variables. Okay, now we're going to step it up and we're going to do a system of quadratic inequalities, a system, meaning more than one. We're going to have more than one inequality, quadratic inequality. Okay, so to do this, you basically do the exact same process we just did. You do it twice, and you look for the region that they have in common. Okay, so really you just do this process twice, and we're going to use our calculator to help us with some of the graphing. Okay, so first let's do for y is less than negative x squared plus 3. Okay, y is less than negative x squared plus 3. So I need to graph y is equal to negative x squared plus 3. So to help me out a little, speed things up, I'm going to go graph negative x squared plus 3. Let's graph it, and I'm going to get some points. Okay, so let's trace. It looks like it goes to the point 0, 3. Okay, so let's go ahead and let's trace this. Let's graph this guy. Okay, it goes to the point 0, 3. Okay, and other coordinates on it. Let's trace a few others. What about 1? 1, 2. So then using symmetry, 2, negative 1. Again, using symmetry. So my graph's going to look like that. Okay, and I'm strictly less than, so it needs to be dashed. So let's go ahead and let's dash it in. Add a few dashes to it. Okay, and then now I need to test a point. So let's test a point. Ooh, 0, 0 is inside here. So let's use the point 0, 0 to test. So again, back in the original, this is my x again, this is my y. So when y is 0, negative 0 squared plus 3. So 0 is less than 0. Square root of 0 plus 3 is 3. Is 0 less than 3? Yes. So I will shade, I'm going to shade lightly inside. Okay, so I did the one. Now let's do the other. Y is greater than or equal to x squared plus 2x minus 3. So I want to graph y is equal to x squared plus 2x minus 3. Okay, so y is equal to x squared minus 2x plus 2x, missed a side, minus 3. Okay, let's graph it. Okay, that looks like that. So we have the point we trace, 0, negative 3, 0, 1, 2, 3. Looks like negative 1, negative 4. Okay, let's see, negative 2, negative 3. try 1, 1, 0. Okay, so it's going to be a parabola that looks like that. Okay. All right, so now we need to test a point for this. Test a point either inside or outside. Well, 0, 0 is inside of this parabola opening up. Okay, ignore the one behind it for right now. Okay, it's in between. So let's go ahead and let's use the point 0, 0 again. So let's replace my y with 0 and x with 0. 0 greater than or equal to 0 squared is 0 plus 0. Is 0 greater than or equal to negative 3? Yes, it is. So on this one, I'm going to shade in a different direction. Just because I shaded at that diagonal, I'm going to shade like straight up and down. So it would be in here. Oh, we didn't look at it. It's greater than or equal to, so it's solid. Okay. And so now I'm looking for the points that are common to both, meaning I'm looking for what points were shaded in both pieces. Well, the points that were shaded in both are the ones below this parabola and above that parabola. So it's all the points in here with a solid curve on this one and a dashed curve on that one. So I want to come in and darken that area a bit. So these are the points in this little bubble, this little figure. These are the points that will work in both of these inequalities. So we're looking for the points that work in both. So really, this is just a double process problem. You just have to do it twice. Okay. All right, so now you have some your turn problems. Here's your turn number 1. Graph the inequality. It's very, very simple to example 1. Okay. Your turn number 2, again, is very, very simple to example 1. Your turn number 3 is very, very simple to example 3. Okay. We have been, this whole lesson so far, this lesson has been about graphing inequalities in 2 variables. We're going to look at a quadratic inequality in 1 variable, meaning it has only 1 variable in it, usually an x. For example, x squared minus 6x plus 4 is greater than 0. There's no y in this, it's only an x. Okay, so we're going to solve these. Again, it's a 3-step process, but we can't graph it because it's not a y equals, it's just an x. So these don't technically need graphed in a coordinate plane. We're not going to graph them in xy plane. We're going to graph them on a line because there's only an x, so we're only going to graph them on the x-axis. Okay, so our first step is finding the critical numbers. The critical numbers are actually what make it equal to 0. What make it 0. And then we're going to use what's called a sign graph to then, from our sign graph, once we create our sign graph, then we can write our inequality. Okay, so let's go ahead and let's work through this process on an example. I think that'd probably be the easiest. So my first step, again, is to find the critical numbers. So I need to find the critical numbers here. So to find the critical numbers, I need to figure out what actually makes this thing equal to 0. So what makes x squared minus 3x minus 4 equal to 0? Okay. So I solve this. Well, I think this factors. Let's see, minus 4 plus 1, I think. X squared plus 1x minus 4x gives me negative 3. Yep. So then x minus 4 equals 0, or x plus 1 equals 0. Again, this is how we solve by factoring. So let's add the 4 to both sides on this guy. So x equals 4. And let's subtract 1 on that one, or x equals negative 1. So these are right here my critical numbers, 4 and negative 1. So now I create what's called a sign graph. I just create a number line. I'm going to create a number line over here. And I'm going to put those critical numbers on that number line. So here's 4, here's negative 1, so 0 would be right about there. So I'm going to, let's just go ahead and let's just put our critical numbers. Let's ignore 0 for now. So there's my critical numbers. We're 0 right there, and we're 0 right there. So these are the numbers that make it 0. Now I need to decide which numbers, which interval am I looking at. This broke the number line up into 3 pieces. these pieces down here that are less than -1, the pieces that are in between -1 and 4, and the pieces that are greater than 4. So now I just need to test some points. So I want x squared minus 3x minus 4 to be less than 0. So I'm just going to go ahead and test a point down here. Let's go -3, and I want to see, does that point work? Okay, so again, does that point work? Okay, so we would go -3 squared minus 3 times -3 minus 4. And I get a positive 14. I get positive 14. Is that less than 0? So I get a positive down here. I want it to be less than 0. What kind of numbers are less than 0? Numbers less than 0 are the negatives. I want negatives. But I got a positive down here, so nope, that number down there doesn't work. Let's go ahead and let's try a number in between -1 and 4. I don't know, how about 2? We'll try the number 2. So let's try positive 2. So we'll have 2 squared minus 3 times 2 minus 4. I'm just putting the number 2 into this thing, seeing if it works. I get a -6. I'm just writing the sign. I don't care what number it is. I just care whether it's positive or negative. A -6, and I want negatives here. I want this thing to be less than 0, which is the negative, so it looks like that number worked. Yay! Now I just try one more up here. So let's try one. You need to try one in each interval, so let's try 6. So we'll go 6 squared minus 3 times 6, times 6 minus 4. We get positive 14. So now, so that tells me that every number up here is going to be positive. Every number down here is going to be positive. So really, the numbers that will work in here are the numbers in between -1 and 4. So this tells me that my x has to be in between -1 and 4. So -1 has to be less than x, and x has to be less than 4. So there's my last step, right? My inequality. Okay. If you'd rather write these words out, and again, it's strictly less than because I can't equal 0, it's less than. If you'd rather write this out in words and write x x is between -1 and 4, you can, if this inequality symbol confuses you. But again, this is the shortcut way of writing x in between -1 and 4. -1 is less than all my x's, and all my x's are less than 4. Okay, all right. Okay, let's go ahead and let's do another one. Okay, so here example 5. Again, our first step is to find the critical numbers. We want to find what makes 3x squared minus x minus 5 greater than or equal to 0. So for critical numbers, we want to find where does it equal 0. Okay, where does it equal 0? This thing I don't think factors very nice. So I think I'm going to use the quadratic formula. X equals -b plus or minus the square b squared minus 4ac all over 2a. -b, that's +1 plus or minus the square root of 1 squared minus 4 times 3 times -5 all over 2 times 3. Okay, so I need to take, it's a -1 squared. Okay, so I need to take -1 and square it, minus 4 times a times -5. 61. 1 plus or minus the square root of 61 all over 2 times 3 is 6. Okay, so 1 plus or minus the square root of 61 all over 6. As far as I can tell, I don't think there's any perfect squares in 61. Try a few things. No, I don't think so. So there's my answer. Those are my critical numbers. So my critical number is 1 plus the square root of 61 over 6 and 1 minus the square root of 61 over 6. So now I need to create my sign graph. Okay, so 1 plus the square root of 61 over 6 might be helpful if we had an approximation for that. So let's go ahead and let's do an approximation. Let's take 1 plus the square root of 61, which is that thing, and then divide it by 6. Approximately 1.46. So this one here is approximately 1.46. So 1 plus the square root of 61 over 6 is approximately 1.47-ish. Let's go ahead and let's put that on the number line right there. And then 1 minus square root of 61 divided by 6 is approximately -1 point. So that's going to be down here. 1 minus the square root of 61 over 6, which again is approximately negative 1.14. The approximately's help so then I know when I'm picking numbers whether it's between them or greater than or so forth. Okay, so approximates help because it's kind of hard to know where is that on a number line. What's around negative 1.1. Okay, so again, now I pick points on either side. And I look here, I want to be greater than or equal to 0. Numbers greater than or equal to 0 are positive. So I want to find positive numbers now. Okay, so now I want to try a number on this side of negative 1.14, which, I don't know, negative 4? So let's put a negative 4 in here. 3 times negative 4 squared minus a negative 4 minus 5. We get positive. Woohoo, that's what we're looking for, positive. Okay, and then we want to try one in between. Well, 0 is in between the two. Let's go ahead and let's use 0. Okay, so 0. So 3 times 0 squared minus 0 minus 5. We get a negative. Let's try a number up here. 3. So 3 times 3 squared minus 3 minus 5. And we get another positive. So it looks like all of the numbers all the numbers down here and all the numbers up here, because we want to be, again, positive. Okay. But this one is a greater than or equal to, so I can actually equal this number, and I can equal this number. If you notice up here, I put open dots because we were strictly less than. Here, I'm putting solid dots because we're greater than or equal to. It's got that equal to aspect. So this tells me that x's are going to be less than this thing. So x's are going to be less than 1 minus the square root of 61 over 6. And this up here is x is going to be greater than 1 plus the square root of 61 over 6, because I want all the numbers bigger than that, all the numbers less than that. So my x is either going to have to be in this set or in the other. So there's my solution. Okay, again, you could write your answer in words. X is less than 1 minus square root of 61 all over 6, or x has to be greater than those numbers. Okay, so there's my solution. So as long as I have numbers less than this thing or greater than this thing, they will make this statement true. Okay. All right, so now you have 2 more years from problems, problems 4 and 5. Jot down any questions you have. Come to class ready to discuss.